I welcome you all to this session of engine system and performance, and today we shall discuss about electronic devices and circuits. So, in our last few classes we have discussed about sensors, we have discussed about electronic control unit, engine management system, we have also discussed about actuators. Now, we had seen that electronic control unit and electronic control unit is an important component for the modern engines, and to run ECU we need actuators, we need sensors, because essentially that is the control unit. So, the objective should be to receive a few inputs from different components of the engine block, and receiving some inputs, ECU is having that provision to compare that input, and then if it is not getting matched with the stored data in ECU, then ECU will try to provide some feedback to the actuators to adjust the engine operation, I mean to adjust several functionalities like fuel injection, mass of air to be introduced in the engine cylinder, temperature of the engine block, temperature of the incoming air, temperature of the exhaust gas, all these things, so as to restore them to the design data. I mean, if we can have the situation when engine can run with its designed condition, then efficiency will be maximum, emission level will be minimum. So, in continuation of that, let us now today discuss about the electronic devices which are very important to for the construction of all modern engines, and then we shall discuss about circuits. But before going to discuss this part, let us first discuss about two important signals that we could not discuss in our last class, and these signals are analog and digital signals. So, if I write here, so analog and digital signals, right. We had seen that typically input to these sensors is any physical variable, and that sensor output is an electrical signal. Now, that signal may be an analog signal, that signal may be a digital signal. So, now receiving that signal, ECU, that is the CPU or computer of the control unit, will try to give some feedback to other components, maybe to move or to actuate the actuators, and accordingly physical variables will be optimized, so as to ensure that the engine can run quite efficiently, whether it is a locomotive engine or it is a stationary engine. Now, before going to discuss about the electronic circuits and electronic devices, this is very important to know. Though in recent times analog electronic circuits are getting replaced by digital circuits, our aim should be to discuss about analog circuit. Rather, we can start our discussion with the analog circuit, because it is very easy to understand, rather I can say it can be better understood quite intuitively rather than the digital circuit. Now, what we know until today, that for any sensor output is electrical signal. Now, input to the sensor is any physical variable. Now, any input is converted to electrical signal, physical variable. Sensor will receive whether the input is optimum input or it is getting deviated from the optimum value. The sensor produces proportional electrical signal. I mean, receiving input, sensor produces proportional electrical signal. Now, the question is, input quantity or input quantities may vary with time. So, if it is a case, then since sensors produce a proportional electrical signal. So, it is very likely to expect that if the physical quantities changes with time, then electrical signal also will vary in time. If the signal is varying in time, it can be a continuous variation, it can be kind of discontinuous variation. So, if that is the case, then what type of signal it is. So, let us now discuss this part. I will write a few lines about this, and so essentially analog signal is such type of signal that produces a variable signal and amplitude with time. So, let us write a few lines and then a few important points of this that will help you to get that will help you to make you understand more clearly. So, that as I told you that sensors produce sensor produce or converts, I should write convert, right, the input variables or to a proportional electrical signal. Okay. Now, if it is a case, so that means as I told you that if the input quantity varies, sensor output voltage also will vary. So, if the input quantity varies, the output signal, the output voltage will vary proportionally. Right. So, that means output signal will vary proportionally depending on the variation of the input quantity. A signal, if we go to the next slide, so a signal that produces continuously varying voltage and amplitude, a signal that produces continuously varying voltage and amplitude. With time, with respect to time, is an analog signal. Right. So, there are many examples are throttle position sensor that we have already discussed, or TP sensor, and so throttle position sensor which incorporates variable resistor to produce analog signal. Similarly, that we can have other temperature sensors, all these things, because that engine temperature can or may change with time. And if we need to get input, so basically if the sensor that is receiving input, that is temperature, a physical quantity, that sensor output also will change, the voltage will change continuously. So, that will produce an analog signal. So, that is what is an analog signal, right. Now, question is typically that all analog inputs are supplied with 5 volt with reference to the ground state. All analog signals are supplied with 5 volt with reference to the ground potential. So, just for your information, if I write here all analog signals are provided with 5 volt with reference to the ground potential. So, this is very important to know at least. Now, what I wanted to say that because ECU will receive all these signals, because that is these signals are the sensors output. Now, ECU should have a provision of converting all these analog signals to the digital value or digital signal before giving some information to the actuators. So, this is very important. So, if I write here just for the sake of completeness that electronically control unit or electronic control unit converts these analog signals to digital signals before processing the information. Converts these analog signals to digital signals before before processing the information, because information will be given to the actuators to do some or to resolve the problem, to do some task, but before ECU provides some information to the actuators, ECU needs to convert this analog signal to the digital one. So, now this is all about kind of analog signal. If we draw a schematic depiction, so let me, so this is, you can understand, right. So, this is the analog signal. Right. So, it will change continuously with time. Now, if we talk about the digital, so if I write here digital signal. So, from the definition what we had in the context of analog signal, you can now understand that analog signals produces, that if we go back to the previous slide, we can see that analog signal produces continuously varying voltage, right, and amplitude with time. So, if the signal produces in contrast to continuously varying voltage and amplitude with time, rather discrete in time, then that should be the digital one. So, if we go back to write a few lines and a few important information about the digital signal, let us discuss that part. So, from the definition, from the understanding we have about the analog signal, digital signals are not the, or digital signals do not produce continuously varying voltage and amplitude with time. Rather, the signal, so let me write the a few lines about this. So, in contrast to an analog signal, in contrast to an analog signal or analog electronic circuit that operates in continuous time, right, a digital system operates in discrete instant of time. Digital electronic system operates with or operates in discrete instance of time, right. So, that you can understand this is the digital signal. If we go to the next slide, then we can write that means a signal that produces or represents just two voltage level rather two voltage levels is termed as digital signal, right. So, this is a digital signal. So, that means from the definition itself we can tell that a digital signal has only two states. So, a digital signal has two states 0 and 1. Okay. So, in typical automotive electronic circuits, a typical digital signal, if I erase it. So, as I said you that in typical automotive electronic system or in typical automotive electronic circuits, a digital signal has two states, a typical two states, that is very important, and a typical digital signal is 0, is either 0 that is off, okay, 0 volt rather, I should write 0 volt, or plus 5 volts, that is on. So, this is all about the digital signal. Now, as we have discussed that ECU cannot process data or information until and unless analog signal is getting converted into the digital signal. So, the system or the circuit, if I go to the next slide, let me write again. So, that means the circuit that converts sample analog data to binary values called is called an analog to digital converter, is called an analog to digital converter, ADC, right, analog to digital converter. So, this is very important. As I said you that ECU cannot process data with the analog signal. So, there must be a converter to convert all analog signals into binary values. There must be a provision if we need to convert again these binary values into the analog signal. So, if the device is analog, right, as in the case of an actuator for a control system, as in the case of an actuator as in the case of an actuator for a control system, output binary number must be deconverted to analog format. So, basically output binary number must be converted to analog data, right. So, this conversion, that means if the device itself is analog, as in the case of an actuator for a control system, the binary output binary number must be converted to analog data, and this conversion is done using. So, if I write here again, this conversion is done in a device known as digital to analog converter, digital to analog converter, DAC. So, that is what is important, right. So, if the device is analog, as in the case of an actuator for a control system, output binary system must be converted to analog data, and that conversion is done in a digital to analog converter, in a converter using this. So, we have understood what is analog to digital converter, what is digital to analog converter, and there is a need of having these two converters in the ECU. Okay. So, with this now let us discuss about the electronic devices, and then if time permits we shall discuss about these devices. So, what we have understood that semiconductor devices or solid state devices are the basic building block for the ECU, that electronic control unit. So, basically that without any semiconductor device or devices, ECU cannot run. So, if we need to have a very sensitive ECU, that means receiving signal from the sensor, ECU will do some calculation, ECU will perform some task and give some information to the actuator to correct the problem, and will give some information to the actuator to take a decision on what to do next. So, all these things are done using the ECU in modern engines, and the functionality or the efficiency of this particular unit depends on the solid state devices or semiconductor devices. So, there are many types of semiconductor devices, but typically for the automotive electronic system we shall look into two important types of semiconductor devices, and those are diode and transistor. Now, these semiconductor devices are the most important element to construct almost all modern engines. So, as I said, in this class our focus would be on the two important types of semiconductor devices, those are diode and transistor. As I said, there are many other common linear semiconductor components or semiconductor devices like transformer, inductors, but our focus for this particular class or for this particular subject, essentially for the automotive electronic system or unit, is the discussion of two important semiconductor devices, and those are diode and transistor. So, if I now go to discuss about these semiconductor devices, what should I tell, that electronic devices so for the automotive electronic system or circuit, right, as I said you that semiconductor or solid state devices are very important. And we shall be discussing about two important types, this semiconductor, two important types. One is diode, another one is transistor. So, you know that or diodes I should write, and it is transistors. There are, as I said you that these two are the very important semiconductor devices for the construction of almost all modern engines, but it is not that these two devices are only the semiconductor devices. There are many other semiconductor devices, those are quite different, but there are many other semiconductor devices, but these two devices are quite different from common linear kind of components, such as I told you, inductors, then resistors, and then transformers, capacitors, etc. So, if I write here these two devices, are quite different from common linear components like capacitors, resistors, inductors, and transformers. Okay. So, now in this class, as I said, we shall be focusing on these two, diodes and transistors. So, let us first discuss about diodes, and then if time permits we shall discuss about the transistors. So, if I write here now diode. So, let us now draw the schematic depiction. Right. So, we all know that from our basic understanding on basic electronics subject, that diode essentially acts, all diodes act like a one way valve. So, it allows current to flow in one direction. So, this is basically a diode. So, this is cathode, this is anode. As I said you that all diodes act much like a one way valve, allowing current to flow in only one direction. So, a diode is a two terminal electric device. So, essentially it is two terminal electrical device having one electrode is called as anode, and this is essentially p type semiconductor, a p type semiconductor, and so we can see from the schematic depiction is that we have the two terminal electrical device. That means that device has two terminals, electrical terminals. One is called anode, that is p type semiconductor, and the another terminal is cathode, this is n type semiconductor, right. So, as I told you that these devices act like a one way valve, that means it will allow only to current flow in one direction. Now, depending on this, depending on the bias of these two, polarity voltage or bias across the anode and cathode, we can classify again this. So, let us briefly discuss about these two. So, though these devices allow current to flow only one direction, but depending on the bias, that is polarity of voltage, this current flow will take place. So, typically this will allow, diodes will allow current to flow in one direction depending on the bias, that is between these two electrodes, that is polarity of voltage. Now, when current flows in the forward direction, right, with a plus voltage on the anode. So, as I said that diodes allow current to flow in one direction depending on the bias, that is polarity of voltage, that is bias across the anode and cathode, right. When current flows in the forward direction with a plus voltage on anode, diodes have a low resistance. Okay. So, when anode is having positive voltage, current is flowing in the positive direction, then diode is said to have low resistance. So, we shall be discussing all these parts in a more greater detail together with discussion on the transistors. As I said, these two important elements are the most important elements for the automotive electronic circuit. So, we need to have little more discussion on these two components, what are the different type, their configuration, their characteristics, and this part we will discuss in the next class. So, with this I stop here today. Thank you.